The next topic is called efficient frontier. Efficient frontier approach or technique is first introduced for investment portfolio analysis. It's a method by which we make a trade-off between expected return on the portfolio and the risk the portfolio is exposed to. So if you are allowed, if you're able to withstand a higher level of risk, then you can have a higher level of expected return, and so on. So what is the efficient frontier at various levels of risk? So your risk level of x and x plus 1, x plus 2, and at every level of risk, what is the maximum possible return that you can expect? So then you have a graphical representation of the relationship between the maximum return and the risk. So that's what's called efficient frontier. And in portfolio investment, the compounded annual growth rate is your expected return, and the risk is measured by the standard deviation. So standard deviation is a stand-in for the risk exposure. So in our airline pricing model, so we're going to take a similar approach. Okay, and we will look at two different scenarios. We will say, all right, we have a particular return that we want, say expected revenue. Okay, so we have we got a maximum expected revenue around 18,000, and then you say, all right, that's your mean return, and what is the lower level or the risk of a lower expected revenue? Say, like, instead of 18,000, what if it is only 15,000? What is the probability that you'll end up with only 15,000? And is that probability big? If that probability is big, that's too much risk. If that probability, or say 15 or 14,000 even, okay, if that is an acceptable level of probability, then that may be something that you want to look at instead of looking at just the mean expected revenue. So that's one. And then the second is we will set up a range for standard deviation of return. Once again, that is a stand-in for risk. So given that range of standard deviation, what policy will give us the maximum expected return? So these two can be solved using this efficient frontier approach. So we will go back to the example in which we did not have a price constraint. So the last example that we did was that the Y fare cannot be more than 2 times the Q fare. Okay, so we'll skip that and we'll go back to the one previous to that, where we initially started with a large range for these 3 decision variables: how many seats to reserve, what is the fare for Y class, and what is Q class fare. And then we had 11 different values for reserved seats going from 20 to 30 in steps of 1. Then 11 different values for Y class fare going from 300 to 350 in steps of 5. And then 5 different values for Q class fare going from 135 to 155. And that gave us 605 different trials to look at. That's the one that we did last, and let's go back to that and then run this part one more time. So let's go to the shell file. Now we go to optimize and look at the model settings. So here are the 3 inputs: 20 to 30 integer, that means steps of 1, 300 to 350 steps of 5, 135 to 155 steps of 5, and F6 is revenue, and we are maximizing the mean of that. And there are 600 some, and again let's look at the model settings. So we have 1000 trials, which means we will try all of them. Okay, and there is one thing that I forgot to do in the previous examples, and that is this setting. We need to make sure that um, the multiple CPUs is enabled and the initial seed is 1. Okay, and the multiple CPU is important, but the initial seed, remember, it's a you really don't want to keep a fixed seed, because the only reason you want fixed seed is for us to be able to generate the same result so we can compare and make sure that everything is set up correctly. So okay, now that's done. Now let's go and start optimize. And we have 600 and odd trials to go. So this is going to take 2-3 minutes or even more. But in the video, I'm just cutting off the time that's the silent time when it's going through the iterations. That's why in the video you will see very quickly getting the results. Actually, it's at least taking 3 minutes or 4 minutes to finish. Okay, now we are done. So if you look at the summary here, you see the original and then you have the best. Alright, so let's look at the log. So this gives us all the 605 trials. Okay, this is the summary log. And then stopping options, let's put it in the active worksheet, these 3. Okay, so now let's take this and we will save it here. So this is what I originally had, but it's different. Okay, let's reduce the. Okay, so I'm going to get rid of this. So of the 605 trials, the best is in trial 26. So you have 18, 030. Okay, and well, these will have to. The best decision is 28 reserved seats, 340 for Y class fare, 150 for Q class fare. So let's go back to the entire log, and now the best standard deviation. So if you look at the minimum value of standard deviation of all the 650, you get 1273. So 1273. Okay, so the best revenue is 28 reserved seats, Y fare equal to 340 and Q fare equal to 150. Now the best standard deviation, if we go back here, you get 1273. So let's try to figure out where that 1273 is. So one way of doing that is to highlight this column and do a conditional formatting where we can set that equal to that, so that you get trial number 3. So now you get these 3 as the adjusting the values. Okay. Well, so we need to type that, so I'm going to copy that down here and make the changes and delete what I pasted. So 20 reserved seats, 300 and 135. So, and these are in the border, so if you relax the border, we may be able to get even smaller standard deviation. Okay. And then we can also look at the 10th percentile and see there is a 10% risk or 10% probability of how much would be the expected revenue. So we can go to the model. Okay, so that's the revenue. Okay, so we want 10th percentile, right? So that will be risk percentile, that 0.1. So that gives us 13,720. So 13,720 is the 10th percentile. Okay, so that's going to be the basis for our first example. So what if, okay, suppose that we want a solution such that we can make $14,000 with only a 7% risk. So that's the standard that we want to set. And then how do we go about doing that? So here is the these are the results from all the 605 trials, but we want to set a more precise goal for us, and this is going to be analyzed using the efficient frontier approach.